Hey guys, welcome everybody in this new video. In the last video we've been looking at case structures and how we can use case structures differently from the Boolean application that we have from case structures. Because we can use them with strings, numerics, enums as well. And I'm going to show you how we can use these case structures into a state machine. And a state machine is actually some sort of event or event structure, but a state machine is based on the opposite of sequentially programming or sequential programming. And that's because what we did so far was sequential programming. We programmed from the beginning to the end, and every time we run the program, it's going to from the beginning to the end in one sweep, and we cannot change anything when the program is running. So if we wanted to skip a part in a program, for example, if we're missing a sensor, then it has no use to read out that sensor and actually trying to do analytics with it, because we know there's no use for it. There's no sensor anyway. So depending on the state of a program, or depending on the state of the world around us, we want to skip or start parts of a program. A nice example is, for example, your PC. Because when you start to run your PC, there are a couple states that your PC is in. There are a couple states that apply to your machine. You can think about first, when you start up, it's initializing, it's starting up essential programs, it's starting up your user interface, your everything you sign into, like the automatic startup sequence when you're starting up your email, for example. So that's all in your initializing state. Then there's an idle state, and that idle state is it's waiting for you to give an input. For example, an input can be run a program, but an input can be as well shut down the PC or go to sleep. So it's waiting in the idle state. It's waiting for a user input, and then depending on the user input, it's either going to run a program or it's going to stop or shut down your PC. Alright, so that's what we do that's what a state machine is for. And I'm going to show you a very simple state machine, how we program that. Alright, so let me just open a blank VI. Control T. And we're going to start with the outer shell, which is essentially a while loop. Because we're going to have a continuous program anyway. So that's why we use a while loop. Alright, inside the while loop, Alright, so inside the while loop we want to have the case structure. Because this case structure is, inside this case structure is going to be the programming of the different cases in this case. Alright, so right now the case selector is still controlled with a Boolean input. I want to use a enum right now, and I'm going to show you the enum. So we can use the string, what we use here. So the combo box, for example, to select a couple states, but I really like the enum for this. So we're going into the numeric palette, and then we select the enum constant, and I'm gonna add a couple of states in here, and I do that I can add an item after, but I can also just select here edit items. Alright, so we have one item in there right now in it, and I'm gonna I'm gonna add a couple I'm gonna add the idle in there, and I'm gonna add my program 1. Alright. And I wire this up to my, we're going to start with the initialize state. I'm gonna wire this up to my case selector. Alright, so it's starting with the init, which is the initialize, and I'm gonna remove, which is the default state in this case. It's not necessary to have a default. So let me remove this. Here it is. Alright, so, and in the initialize state, it's going to reset all the variables to 0, for example, or reset all the exerting for, or it's going to reset our test machine. That's what's doing in the initialize state. Once that's finished, it's going to into the idle state. And how do I do that? By using this enum in this initialize state, and I'm going to the idle state after my initialize state, and I'm going to wire this up via a shift register into this tunnel. So let me replace this with a shift register. Alright, and you know, with this shift register, this is the input value. That's the value that's been used in the first loop iteration, and then afterwards, this in the second iteration, the output value of this shift register is going to be the input value of the previous loop. So I can just wire this up like this. So that means first loop iteration is going to run the initialize case, and then the initialize case closes off with this idle enum, and this idle enum is fed back into the shift register, and the second loop iteration, this readout is going to be idle, and that's going to run the idle. And what I really want to do right now is, okay, while the computer is idling, I want the user to choose either start a program or stop. So stop the machine. So I'm gonna have a stop button in here, which is going to be the stop button. Hey, what is? Create a control. Right. There it is. And for the other one, I'm going to have a button like this, and I'm going to call this program 1. And if the user wants to start program 1, he just clicks on this button and it's going to start program 1. Like that. Right, that's better. And I want to have an indicator, a string indicator, which is going to tell me what state am I in. Oops, there it is. And I can leave this outside, and I need to leave this inside. Alright. What I want the user to do is, if he clicks program 1, then he needs to run program 1, and if not, he needs to return to idle again. And I'm going to use, I can use actually the case structure, this one, and I can select with. Alright, so if it's true, I want to, let's copy this enum. I want to run program 1. And if it's false, then it needs to go back to idle. Oops. Need to copy this one. There it is. Idle. Alright, and if you press a stop, then we're stopping or breaking out of the loop. It actually gives me an error here, which is, we'll see that later. And by program 1, let me first go to program 1. I need to add a case after this. So right now I only have the cases init and idle, and I need to add the case of program 1 as well. I can just select add case after, and it automatically reads out this enum and says, alright, the next value that you can select in this enum is program 1. So in here I can have program 1, so I can have maybe do a calculation, or let me just use a prompt. Alright, and I call this program, or you just started program 1. And I'm getting an okay signal, whatever. Alright, and after program 1, we need to go back to idle again. So I'm copying this enum again, and we're going back to idle. Now I still can't run the VI. There are two problems. I have this tunnel, it does not have an assignment. And that's because in these case structures, if you have a loop tunnel like this as an output, then it always needs to have, you need to output a value. So what I can do right now is, for example, if I run this program, I can create a constant which is false. That means that every time I run this case, I get a false output here, which is read out here, and it's not stopping the loop. There's a different way to do this actually, and that's by just use default if unwired. I can just select that one. That means that it will always be false by default. That's because of this button. So that means in the other cases it will be false as well. And now there is no error anymore, so I can run my program. And so it's initialized, now it's running in idle. If I select program 1, it runs program 1, and now it's in idle again. And I can press stop, and then I break out of the loop. Right, let me clarify it a little bit more by writing here or displaying here in what state we are. And I can do that by using this variable. And you know, in the last module we used local variable, and I'm gonna use that right now as well. Right, so in it I'm going to write a local variable, and I'm going to change the state into create a constant. We're now in the initialized state. Let me copy this into the idle state as well. So now we're in idle. And I need to have it in program 1 as well. Right, and give me a little bit of a delay in here. Because to be honest, we're not starting up this PC in 1 millisecond. We're going to start it up in 1000 milliseconds. So it takes us a second. Alright, so if we run a program right now, you can see it's initializing for a second. Now it's in idle, and it's in this state, and it's waiting for me to either select, or it's actually continuously running, but it's running in idle as long as I'm not selecting stop or program 1. And when I select program 1, then I just started program 1, and if I select stop, then I stop and break out of the loop, and I stop our program. Right, now this is one way to use this event structure. If we're going into if we're adding more programs, for example, then it would be better to actually have an event structure in here. And I'm going to show you this event structure set up in the next video.